Welcome to Physics 12 101. Today's lesson is on kinetic energy. What exactly is kinetic energy? Simply put, kinetic energy is the reason jumbo jets can soar high in the skies. It's the reason race cars can set world record lap times and reach world record speeds. It's the reason Usain Bolt is the fastest man alive. Kinetic energy is defined as the energy an object has because of its motion. But how do we calculate kinetic energy? Well, it's actually very simple. Kinetic energy is equal to half the mass of an object times the velocity squared. Let's try a problem together. A car has a mass of 1.5 times 10 to the 3 kilograms and is traveling at a speed of 85 kilometers per hour. Calculate the car's kinetic energy. First, we should try and picture what's going on. First, let's write out our formula. Next, let's plug in the value of our mass. If we convert 85 kilometers per hour to meters per second, we'll get approximately 23.6 meters per second. Finally, we can solve the equation and get an answer of 4.18 times 10 to the 5 joules of energy, which is how much kinetic energy the car has. Now let's talk about work theorem, which states that the total work done on an object equals to the change in kinetic energy. Now let's try a problem together again. A blue whale with a mass of 1.5 times 10 to the 5 kilograms is swimming with a speed of 6.1 meters per second. A nearby boat startles the whale, and the whale increases its speed to 12.8 meters per second. Calculate the work done on the whale by the water. First, let's picture what's going on. We have a whale, and he's trying to get away from this boat because he's really scared. Now we can write out our formula, but this time we'll have to work with initial kinetic energy and final kinetic energy in order to get the difference so that we can get our work done. Let's start by plugging in our mass. Then we can plug in our initial velocity. Finally, we can solve for our initial kinetic energy, which is 2.79 times 10 to the 6 joules. Next, let's solve for final kinetic energy. We have the same mass value, but this time we'll plug in our final velocity. The final kinetic energy is 1.23 times 10 to the 7 joules. Next, we plug in our values into our work theorem formula. Finally, we solve the equation, and we see that 9.5 times 10 to the 6 joules of work was done. Now let's recap what we've learned today. Kinetic energy is the energy an object has due to its motion. And work theorem states that the total work done on an object is equal to the change in kinetic energy. This has been Physics 12 101's lesson on kinetic energy and work theorem.